Hi children, how are you all? I hope all you are fine. Children, what we discussed in the previous video worksheet which is related to concept 1. Now here in this video we are going to discuss about that representation of rational numbers on a number line. Okay, now here see that representation of rational numbers on a number line. Okay, now here see that representation of rational numbers on a number line. First see that representation of integers. Once observe that how to represent integers on a number line. This is the number line of that integers, negative integers and positive integers. In that middle we are having that 0. Understand? Right side of 0 here 1, 2, 3, 4 and so on. Positive integers. And left side of 0 we can observe that here negative integers and so on. Understood, ma? This is the representation of integers on a number line. Now here rational numbers, see that rational numbers how to represent on a number line. Rational numbers, see that this is that number line of rational numbers. In that middle we can observe that 0. Next here this is 1 and this is 2. This is minus 1, this is minus 2 and so on. Here you may get the doubt, here these two also integers only, no? Then why you represent on a rational numbers? We know that integers are rational numbers. And see that fractions where we can represent. Now see that ma here 0 to 1. First I am going to take here 0 to 1. 0 to 1, I want to divide this one as 3 parts. How many parts ma? 3 parts I want to divide this one. Okay, 1, 2, 3. Now here this one is 1 by 3, 2 by 3, 3 by 3. 3 by 3 after cancellation again you will get it as 1 or not? Yes. And here this one divided into 3 parts, no? Next one also I divided into 3 parts. Then how much I will get ma here? This is 4 by 3, 5 by 3, 6 by 3. In continuation I am writing. See that. 1 by 3, 2 by 3, 3 by 3. And here 4 by 3, 5 by 3, 6 by 3. Children, here we can observe that one more thing, that is 1 by 3, 2 by 3. These two are 1 by 3 and 2 by 3. Those two are proper fractions. And in the same way, improper fractions, what we can say here, numerator is greater than the denominator and the numerator is equals to denominator also, no? Then here 3 by 3 is also an improper fraction. 4 by 3 improper, 5 by 3 improper, 6 by 3 improper. Okay, here we can observe that 6 by 3 means again you will get it as 2. Now here the proper fraction value is always less than 1. Yes or no? Here these are proper fractions, this value is less than 1 only, no? And here improper fraction value is equal to 1 or greater than 1. Greater than 1. Understood, ma? Now here see that this is the representation of fractions on a number line. Here fractions only considered as rational numbers, no? So this is the representation of rational numbers on a number line. Understood? Now come to the left side of 0. Left side of 0 also I want to divide it into 3 parts. Minus 1 by 3, minus 2 by 3, minus 3 by 3. Minus 3 by 3 is nothing but again minus 1. And here again divided into 3 parts, minus 4 by 3, minus 5 by 3, minus 6 by 3. Minus 6 by 3 means again that is minus 2. Understood, ma? So this is the representation of rational numbers on a number line. Okay. Now here I will give you that 2 by 3 or minus 3 by 4 is there. Minus 3 by 4. Represent it on a number line. And here 3 by 4 plus 3 by 4 also represented on a number line. How to represent this rational numbers on a number line? Here see that 3 by 4, 3 by 4. Proper fractions or improper fractions, ma? proper fractions only, no? Proper fractions means less than 1, which means here 0 to 1. Here also 0 to minus 1. Understood? And denominator is having that how many parts, ma? In denominator we can observe that 4. Which means 0 to 1 divided into 4 parts. 1, 2, 3, 4 parts. And in the same way here also 4 is there on negative side. That's why here this one also divided into 4 parts. Okay. Now here 1 by 4, 2 by 4, 3 by 4, 4 by 4. And in the same way here minus 1 by 4, minus 2 by 4, minus 3 by 4, minus 4 by 4. Minus 4 by 4 means again you will get it as minus 1 only, no? And here 4 by 4 means after cancellation what you will get here? 1 only, no? Yes. That's why here say that this is the representation of rational numbers. Now here minus 3 by 4. Where we can observe that minus 3 by 4, ma? Here this is minus 3 by 4. And this is 3 by 4. This is the representation of given rational numbers on a number line. Understood, ma? How to represent rational numbers on a number line? Yes. After this one we are having that how many rational numbers are lies in between given two rational numbers. For example, 1 and 0, minus 1 and 0 are the rational numbers. How many rational numbers we can observe here? In between 0 and minus 1, how many rational numbers we can observe here? 3. Okay. For example, I want to divide this one as 0 to minus 1 as 10 parts. Minus 1 by 10, minus 2 by 10, minus 3 by 10, minus 4 by 10, minus 5 by 10 and so on, minus 10 by 10. Minus 10 by 10 means minus 1 only, no? Yes, of course. Now here how many rational numbers we can observe here? 9 rational numbers we can observe in between 0 and minus 1. Understood, ma? And in the same way, I want to divide that 0 to minus 1 or 0 to 1 as 100 parts. At that case, how many rational numbers in between a 0 and 1 you will get? 99 rational numbers you will get. For example, I want to divide it into 1000 parts. You will get it as 999 parts. I want to divide it into 1 lakh parts. So 99,999 parts you will get. 99,999 rational numbers lies in between 0 and 1 if it is divided into 1 lakh parts. Oh, understood, ma? That's why here how many rational numbers are lies in between any two rational numbers? Infinitely many rational numbers lies in between two given rational numbers. Understood, ma? Say that. What is the next concept? Number of rational numbers. Number of rational numbers lies in between two given rational numbers. In between two given rational numbers. Understood, ma? How many rational numbers we can observe here? Infinitely many rational numbers lies in between any two given rational numbers. For example, how many natural numbers are lies in between two consecutive natural numbers means no natural number lies in between two consecutive natural numbers. Okay. Natural numbers. How many numbers are there in between? 0. For example, and in the same way, related to natural numbers. Related to whole numbers, how many whole numbers lies in between 2 and 3? 0. In integers, how many integers are lies in between 2 and 3? Here 0. And in the same way, come to that rational numbers, how many rational numbers lies in between 2 and 3? Here infinitely many rational numbers. Infinitely many rational numbers lies in between 2 and 3. How it will be? Just see that example, ma, here. For example, here the given rational numbers are 2 by 3 and 1 by 4. 2 by 3 and 1 by 4. Understood? Now here see that children, 2 by 3 and 1 by 4 are the given rational numbers. How many rational numbers are lies in between given two rational numbers means here we are having that some methods. Okay. So first one is by taking that equivalent rational numbers also we can find that in between how many rational numbers are there we can find. And in the same way, by taking the decimal numbers also we can find that. And in the same way, 3 formulas also there. These all methods we will discuss in this video. Okay, see here ma. The first one is equivalent method. See that here LCM of 3 and 4 is 12. Okay, now here 2 by 3 into, here dash is equals to, here the denominator is 12 ma, 3 into how much is equals to 12? 3 fourths. Then here this is also 4. 2 fourths 8. Next 1 by 4 into dash, which is equals to, the denominator is 12. 4 3 is 12, then here this is also 3. 1 3 is 3. Understood? Now what numbers are there here? In between, see that on a number line, in between 3 by 12 and 8 by 12, how many rational numbers are there ma here? We can observe that here the rational numbers are 4 by 12, 5 by 12, 6 by 12, 7 by 12. Understood? Here 4 rational numbers we can write in between 3 by 12 and 8 by 12. 3 by 12 is nothing but 1 by 4 and 8 by 12 is nothing but 2 by 3. Understood? And in the same way here, first I taken that 8 by 12 and 3 by 12. Now 2 by 3, which is equals to, how much you got ma here? 8 by 12. And in the same way here, 1 by 4 is equals to 3 by 12. Okay, now I want to write that one more equivalent fraction to this one. Both numerator and denominator multiplies by 10. Okay, here also I want to multiply both numerator and denominator by 10. Here you will get it as 8 tens 80 by 12 tens 120. Here 3 tens 30, 12 tens 120. Okay children, now here on a number line just observe that 30 by 120, here 80 by 120. In between how many rational numbers we can observe that? Say that 31 by 120, 32, 33, 34, 35, 36, 37 and so on up to 79 by 120. Okay, these all are the rational numbers which are lies in between 30 by 120 and 80 by 120. So children, this is one of the method to find that write 10 rational numbers in between 2 given rational numbers, or write n rational numbers in between 2 given rational numbers. Okay children, this is one of the method. Second method is the decimal method, by converting into the decimals if that given numbers is there in that multiple choice questions. Okay, at that cases easily you can check the decimal numbers, that is easily you can find that. Understood ma? Now here say that by using that formulas, here we are having that 3 formulas. What are those 3 formulas ma? Say that the first formula is, see the children, next n rational numbers lies in between any 2 rational numbers. Before that here first formula is, what is that? Find a rational number. A rational number lies in between x and y. Here x and y are rational numbers. So lies in between, exactly in between which rational number is there means the formula is a rational number lies in between x and y is x plus y by 2. X plus y by 2. For example, say that find a rational number, find a rational number, find a rational number lies in between 1 by 2 and 3 by 4. 1 by 2 and 3 by 4. So in between exactly which rational number is there? Understood? Now here say that let x is equals to 1 by 2 and y is equals to 3 by 4. Y is equals to 3 by 4. Now here what is that formula ma? Here the formula is the rational number which is lies in between. Rational number lies in between 1 by 2 and 3 by 4 is, what is that formula here? X plus y by 2. Here x is equals to 1 by 2 plus 3 by 4 by 2. Understood? 1 by 2 plus 3 by 4 by 2. which is equals to here, see that, take the LCM of 2 and 4, again you will get it as a 4 only, no LCM, yes, and here 1 into 2 into how much is equals to 4 ma, 2 2's 4, plus 3 whole by 2, which is equals to 2 1's 2 plus 3, which is equals to 5 by 4 whole by 2, which is equals to 5 by 4 into 2. 5 by 4 into 2 means 5 by here, which is equals to 8. 5 by 8. Yes or no? See that here 5 by 4 to 8. Just observe that in between 1 by 2 and 3 by 4. 1 by 2 and 3 by 4. Understood ma? Here LCM we got it how much? 1 by 2 into LCM is equals to here 8, we got it as LCM only, no? Yes. Sorry, 4 is that LCM, no? Yes. 4 is the LCM. And here 2 into 2 is equals to 4. Numerator also multiplies with 2. 1 into 2 is equals to 2. 2 2 is 4. Clear? 3 by 4, which is here multiplies by 1 by 4. Sorry, 1 by 1. Why? Because here 4 into 1 is equals to 4, no? That's why here 3 1's 3. Okay. Now here 2 by 4, 3 by 4. But here what number we got ma here? That is 5 by 8. Which means here multiply both numerator and denominator again by 2. Then how much you will get? 2 2's 4 by 4 2's 8. And this one also multiplies by 2. 3 2's 6 and here 4 2's 8. Now just observe this one ma here. This is 4 by 8. And this is 6 by 8. Exactly in between which number is there here? 4 and 6 in between which number is there? That is a 5 by 8 only, no? That number only we got here, that is 5 by 8. Understood? See here what is that formula? The number which is lies in between. In between means only one number is there. Exactly in between two given rational numbers. How many rational numbers means? Exactly one number. Exactly in between they are asking, no? To find that one middle number, in one between number which is lies in between two given rational numbers, the formula is x plus y by 2. Understood ma? It's average. Okay. And this is the first method. Second one is find n rational numbers. N rational numbers in between. Find n rational numbers in between x and y, where here the condition is where x comma y are non-fractional numbers or non-fractional numbers. Okay, then here what is that formula ma? That is x into n plus 1 by n plus 1. Comma y into n plus 1 by n plus 1. Here the condition is what is that? X and y are rational numbers, but those two rational numbers are non-fractional numbers, which means integers we can take. Why? Because all integers are rational numbers only, no? That's why here x and y are integers, and in the same way those two are rational numbers. Understood? Now here see that example. Find 10 rational numbers. 10 rational numbers. Find 10 rational numbers in between 2 and 6. 2 and 6. In between 2 and 6, how many rational numbers ma? 10 rational numbers. Here let x is equals to 2, y is equals to 6, n is equals to 10. Which means here 10 rational numbers, no? N is equals to number of rational numbers. Now here what is that formula here? X into n plus 1. X means 2 into n plus 1 means 10 plus 1 by 10 plus 1. Comma. Here another number is 6 into 10 plus 1 by 10 plus 1. Clear? Now here 2 into 10 plus 1. 2 into 10 plus 1 is 11 by 11. We should not cancel that 11 and 11. Here n plus 1 and n plus 1 same only, no, but we should not do that cancellation. And here 6 into 11 by 11. 6 into 11 by 11. Now here 2 into 11, which is equals to 22 by 11. and here 6 into 11 means 66 by 11. Okay ma, these two fractions we got it now. Now here 10 rational numbers they are asking, no? So 10 rational numbers means how many 10 rational numbers, how we can write 23, 24, 25, 26, 27. Those all are the rational numbers which are lies in between 2 and 6 only, no? Understood? Now here say that 23 by 11, 24 by 11, 25 by 11, 26 by 11, 27 by 11, 28 by 11, and in the same way 31 by 11, 32 by 11, 33 by 11, 3, 6, 9, here 65 by 11. These are the numbers lies in between 22 by 11 and 66 by 11. Understood ma? Which is just like that, in between 2 and 6 these are the numbers. 2 and 6 we will get that values also here. Okay, here you will get it as a 2 point something here, and this is a 2 point, this one also you will get it as 2 point something, and this is a 5 point something. Okay, so these values lies in between 2 and 22 by 11 and 66 by 11. Here when we can use this formula ma, if that x and y are non-fractional numbers, then you can apply this formula. If that x and y are fractional numbers, then which formula we can use here? If x comma y are fractional numbers, then find the difference. Then d is equals to y minus x by n plus 1. This is the formula. Okay, here d is equals to difference, x is equals to first rational number, x is equal to first rational number, y is equals to second rational number, and n is equals to number of rational numbers. Understood ma? Now here say that then the rational numbers are x plus d, x plus 2d, x plus 3d, and so on. These are the rational numbers which are lies in between x and y. Understood? Now here see that example. Find 5 rational numbers. 5 rational numbers in between 2 by 3 and 4 by 5. 2 by 3 and 4 by 5. How many rational numbers ma? 5 rational numbers they are asking. Now here say that x is equals to 2 by 3. Let x is equal to 2 by 3. Y is equals to 4 by 5. And here n is equals to 5. First we need to find the difference, no? D we need to find out. D is equals to y minus x by n plus 1. Y is equals to 4 by 5 minus 2 by 3 whole by 5 plus 1. Clear ma? Now here say that already you learnt about this one in fractions, no? Once again say that in that rational numbers also again operations there, we will discuss in that next videos. Just to say that here in fractions already we know that 5 3 its LCM is 15, and here say that 4 3 is 12 minus 2 5 is 10 whole by 5 plus 1 is equal to 6 only, no? Yes. Now here 12 minus 10 which is equals to 2 by 15 into 6. 15 into 6. How much you got here? 2 by, here 15 into 6 is equals to 90. Okay. If you want to do that cancellation, or if you don't want to do that cancellation, that is your wish. Easily you will get that answer. Say that 2 by 15 into 6 is equals to 2 by, here which is equals to how much ma? 90. Okay. Now here first rational number. Okay. First rational how much ma? First rational number is x plus d. Here x is equals to how much? 2 by 3 plus 2 by 90. Here the LCM of 3 and 90, we know that 90 is a multiple of 3. Then easily again you will get it as 90 only the LCM. Okay. Now here 2 into 3 into how much is equals to 90 ma? 330 is 90 plus 2. Then here 230 is 60, 60 plus 2, 62 by 90. 62 by 90. And in the same way second one, x plus 2d which is equals to 2 by 3 plus 2 into d is equals to 2 by 90. Then you will get this one as 2 by 3 plus 4 by 90. Again the denominator is 90. Then here 2 into 330 is only 90 plus 4. 230 is 60 plus 4 by 90. We will get it as 64 by 90. Understood ma? So in this manner find that remaining values. Okay. And in the same way say that 4 by 5 means after converting into that 90 you will get that these values only. We will check that one. See here. 2 by 3 plus 3d no? D is equals to how much you got it? That is 2 by 90. 2 by 90 which is equals to 2 by 3 plus 6 by 90. Again the denominator is 90 and here 2 into 30 plus 6 which is equals to 66 by 90. By cancelling these two you will get it as continuation numbers ma. Okay. Next fourth one is 4 into 2 by 90. Then easily you can write this one no? Plus 8 by 90 which is equals to 2 into 30 plus 8 by 90 which is equal to 68 by 90. And in the same way 2 by 3 plus 5 into 2 by 90 which is equals to 2 by 3 plus 5 to 10 by 90. Here by taking this one as 90 denominator and here 230 is 60 plus 10 which is equals to 70 by 90. Understood ma? Now here 5 rational numbers. 5 rational numbers in between. What are the numbers here? 2 by 3 and 4 by 5 are, what are the numbers? 62 by 90, 64 by 90, 66 by 90, 68 by 90, 70 by 90. 4 rational numbers. These 4 numbers we got it or not? Yes, of course. And see that here 2 by 3, 4 by 5, there no checking process. See that 2 by 3 to make that denominator as 90. 3 into how much is equals to 90 ma? 30 is only no? 230 is 60. And here 4 by 5. Here the denominator is 90. 5 into how much is equals to 90? Sorry. 5 into how much is equals to 90 ma? Here 5 18s. Okay. Now here 4 into 18 is equals to 72. Okay. Now here see that in between 60 by 90 and 72 by 90, how many rational numbers we written here? 5 rational numbers. Now just check that these all are the rational numbers which are lies in between 60 by 90 and 72 by 90 or not. On the number line just check that. Here this is 60 by 90. This is 72 by 90. And what values we got it ma here? What values we got here? 62 by 90. Here this is 62 by 90, 64 by 90, 66 by 90, 68 by 90, 70 by 90. Yes or no? 5 rational numbers we got it or not? Understand ma? So children, this is another method. So finally how many methods are there here? 3 methods, a formula based 3 methods here. One is x plus y by 2, another one is x and y are non-fractional numbers, then x into n plus 1 by n plus 1, y into n plus 1 by n plus 1. If that x and y are fractional numbers, then here we need to find the difference. What is the difference? How to find? Y minus x by n plus 1. After that x plus d, x plus 2d, x plus 3d, like that. Understood ma? So these 3 are formula based. And along with that, what methods I told you? Equivalent method, and in the same way by converting into decimals also we can find that rational numbers which are lies in between two given rational numbers. Understood ma? So up to here this is the second concept, which means concept 1a. Okay, concept 1a completed. In that next video we will discuss about that related questions. Okay, thank you all.